Today we're going to learn about applications of linear equations in real-world context. Now, it said that we have learned in primary school how to solve word problems using the model method. However, not all word problems can be solved using it. For example, you may wish to try solving the following problem using the model method. A man is 5 times as old as his son. 4 years ago, the product of their ages was 52. Find their present ages. You will realize that the above problem cannot be solved using the model method. Therefore, there is a need to learn a new method called the algebraic method. So this algebraic method is just replacing the model method that you've learned in primary school. Because the model method that you've learned in primary school is either like too slow or is sometimes limited to only some problems. So there might be some problems that you cannot solve with a model method. It's limited, right? So you need to learn use the algebraic method to solve it. That's why you learn the linear equations here. So let's just take a look at example. A man is 5 times as old as his son. In 10 years' time, the sum of their ages will be 76. How old was the man when his son was born? Now the left column below shows how the problem is solved using the model method, the way you usually do in primary school. Now, because it says that the man is 3 times as old as his son, so in the model method you will draw 1 box for son and 3 boxes for man. In 10 years time, the sum of their ages will be 76. So what you're going to do is 10 years time. So you add 10 to the first box and add 10 to the 3 boxes for the man, and their sum will be 76. Alright, so 4 units of these x's, 1, 2, 3, 4 plus 20 is 76. That means 4 units is just 76 minus 20, right? The 10 and 10 here is subtracted from the 76. Now because 4 units is 76 minus 20, which is 56, that means 1 unit is 56 divided by 4, which is 14. Now when his son was born, the man was 2 times 1 unit, 14. You know why? Because when the son was born, which is this one here, we subtract both ages by x, so the son ages will be 0, which means he just born, and then he was just born, and then the man subtracted by s only 2 units here, right? So 2 times 14, 28. That will be the model method that you usually do. Now in algebraic method, you don't need to do this kind of modeling. Instead you will just need to form an equation. So a man is 3 times as old as his son. That means if the son is x, the man is 3 times x, 3x. So we put x and 3x. In 10 years time, so after 10 years, so we plus both by 10. The sum, which we plus here, will be 17. So that means the equation is x plus 10 plus 3x plus 10 equals 76. And after that, x plus 3x become 4x, 10 plus 10 become 20. So 4x plus 20 equals 76, which is later become 4x equals to 56, and then the x later divided by 4 become 14. So almost the same way, except because you already learned about linear equation, you can just immediately form the equation rather than doing this modeling, but in the end they will be the same. So maybe it will take time to get used to it, but I recommend you to just leave this method. So just try to learn this method. Yeah, by doing it several times you will get used to it, and it'll be much faster and easier to do this than this model method. Let's take a look at another example. The sum of three consecutive even numbers is 60. Okay, we have found in the work example 6 that a formula for the sum of s of any three consecutive even numbers is s equals 3n plus 6. Yeah, take a look back at the work example 6. There we learned that the sum of three consecutive even numbers is x plus 2 plus x plus 4. Yeah, so that will make it 3x plus 6, or maybe here they use n. So n, yeah. So 3n plus 6 equals 60, and then just solve the equation. The moment you get n equals 18, then the next consecutive number, even number, will be x plus n plus 2, which is 20. The next one will be n plus 4, which is 18 plus 4, 22. Okay. Michael walks at an average speed of 3 km per hour for 40 minutes before running for half an hour at a certain average speed. If he travels a total distance of 6 kilometers, calculate his average running speed. Okay, running speed. So for now, we see different unit here. This is one in hour. This one is in minutes. So we have to make them the same unit. So let's change minutes to hour first by dividing it by 60. So 45 divided by 60 become 3/4 hour. Now 3 times, yeah, okay, the total distance he walks. So when he walks, the speed is 3 and the time is 45 minutes, which is 3/4 hour. I'll remind you again, the formula of distance is just speed times time. So speed is 3, the time is 3/4 hours, so times it become 9/4 kilometer. Because this is kilometer, that's why this is kilometer. Total distance when he runs. Okay, we don't know the speed when he run, right? It is what they ask, his average running speed, right? So we don't know yet. We symbolize as x, so we are going to find this x times the time, which is running for half an hour. That means 1/2 hour. So x times 1/2 is x/2. Now the total distance of 6 kilometer. That's why we find the total distance when he walks and when he runs. So we can form an equation which is 9/4 plus x/2 will be 6, right? The total distance, right? So yeah, it's 6. So 9/4 plus x/2 equals 6. Now you convert to like fractions. So x/2 become 2x/4, which means you times 2 to both the numerator and denominator, so they both have over 4, and then you can group them together, and then the 4 you can move to the right side, like cross multiplication thingy, so become 6 times 4 and 24, and then just solve the remaining equation. That's it for today's video, yeah, about real world application of linear equations. So yeah, now it's time to abandon the model method and start using the linear equation method. Okay, bye.